Hello everybody, and welcome to your linear algebra review on Gauss-Jordan elimination with no solution. My name is Jason, and I work for the ASU Tutoring Centers. Now, if you haven't seen my previous videos on Gauss-Jordan elimination with one solution or infinitely many solution, I highly recommend checking those out before watching this one. Those will provide some more context and background before hopping into this. We're just going to jump directly into this problem. So we're trying to solve this equation here. This matrix equation that we have. And how we typically solve them at this stage in linear algebra is we toss the system into an augmented matrix. So we take our matrix on the left-hand side and we augment it with our solution vector here on the right-hand side. And then our goal is to get this into reduced row echelon form. Now, there's tons of ways we can go about that, right? Typically, the easiest way is to start by getting a 1 in this top left position. So where this 2 is currently, we want to get that to a 1. So now what we could do is we could just divide the top row by 2, but then we'll get some messy fractions, right? Like this will become 1/2 and this will become -1/2. And nobody likes messy fractions. So maybe instead I can swap the first row out with a different row that's a little bit easier to get a 1 in that left position. In fact, if we look at this row right here, the second one, everything is a multiple of 3 in this row, right? 3, 3, -9, 24, all multiples of 3. So I could divide everything by 3 without getting messy fractions, meaning I could get that 1 in this left position here. So maybe my first step will be to swap the first and second rows. And then my next step would be to divide that first row by 3. So let's see this in action, right? So I'm doing row 1 and I'm swapping it with row 2. It's like a double arrow. So now I have 3, 3, -9 augmented with 24. And I have 2, 1, -1 augmented with 6, and -1, -2, 8 augmented with -14. And now that I have the 3, 3, -9 up top, I can go ahead and divide by 3. There we go. And then everything else stays the same. So this was a little bit nicer, right? So I was able to get that 1 in that top left without getting any messy fractions. Let me just fix my handwriting real quick. There we go. Cool. And once you have that 1 in that top left position, your goal then is to get zeros beneath it. Okay, so we want to get a 0 in this position and a 0 in this position. Okay, I'm going to go a little bit faster through this one. Again, if you wanted to see more step-by-step, definitely check out the previous videos on Gauss-Jordan elimination with one and infinitely many solutions. So I'm actually going to do 2 steps in one right here. So I'm going to get the 0 in the second row. So we'll do that by row 2 minus 2 row 1. And I'm going to get the 0 in the third row. You get that by row 3 plus row 1. So doing these 2 row operations will give me a 0 in my second row and then a 0 in my third row. So I have 1, 1, -3, 8. So I'm doing row 2 minus 2 row 1. So I have 2 minus 2 times 1. 2 times 1 is 2. 2 minus 2 is 0. Then I have 1 minus 2 times 1. 2 times 1 is 2. 1 minus 2 is -1. Then I have -1 minus 2 times -3. 2 times -3 is -6. -1 minus -6 would be -1 plus 6, which would be 5. And then I have 6 minus 2 times 8. 2 times 8 is 16. 6 minus 16 is -10. Okay. And then a similar process for row 3 plus row 1. I end up doing it all and I get this. So now immediately, just at this step, should already be a red flag. Because if we look at our left-hand side, the second row and the third row are the exact same on the left-hand side. So because they're the exact same, the right-hand side should also be the exact same. But it's not. We have a -10 and a -6. So that's already like screaming in your head that, uh-oh, there's a problem here. We're probably going to have no solutions just based on this, right? But let's kind of see it to fruition. Let's do a little bit more. So once we get those zeros in the second and third row, the next step would be to get a 1 in this position. So we would have to do negative row 2, negative 3, 8, 0, 1. So we flip all of the signs, positive 10. Cool. And then to get a 0 beneath that 1, we would go ahead and take row 3 plus row 2. Negative 3, 8, 0, 1, negative 5, 10, 0, 0, 0, 4. So again, right now, here's another red flag. We can pretty much end it here if we wanted to. We have 0, 0, 0, 4, which is telling us that 0 equals 4, which is clearly not correct, right? Obviously, 0 does not equal 4. But if I wanted to see it all the way to reduced row echelon form, there's technically still one more step I would need to do. Because this one is a pivot or a lead variable, we would have to make a 0 above it for it to be in reduced row echelon form. So I could do row 1 minus row 2. That would be 1, 0, 2, negative 2, 0, 1, negative 5, 10, 0, 0, 0, 4. So now it's completely in reduced row echelon form. Again, I didn't need to really get it to this point. I knew at this step that I had no solution. In fact, I knew at this step that I had no solution, as I mentioned earlier, right? The left-hand sides are the same, but the right-hand sides are different. So at any one of these steps, so at here, and at here, it would have been sufficient for you to argue that, hey, I'm not going to have any solutions. We have a problem here, right? So we know that our equation has no solution. And again, the easiest way to see it is definitely this step here, where we have on the left-hand side 0x1 plus 0, or sorry, 0x plus 0y plus 0z, which is just 0 equaling 4, which is certainly false. So no solution. And because there's no solution, we would say our system is inconsistent. Right? Consistent, as we mentioned in previous videos, means that it has at least one solution. So in the case of linear systems, that means it has either one solution or infinitely many. If it has no solution, we say it's inconsistent. Fantastic. Okay, let me clear that off and go on to the next slide. So thank you for watching. Thank you for joining me. As I mentioned at the beginning of the video, I work with the ASU tutoring centers. So if you want more information about the free resources we have on all 4 of the major campuses and online, please check out tutoring.asu.edu. If you specifically want more videos like this one that go over specific concepts from your class, or maybe you want to see what our upcoming review session schedule is for your the reviews of the exams in your class, check out this link right there. All right, that is all I have for you. Again, have a wonderful day.